Today we're looking at radicals and rational exponents. We're going to evaluate nth roots and rewrite expressions using radicals and rational exponents. So numbers 1 through 6, we're going to find a solution for number 1. This is not all of the solutions. We're just going to be looking at the positive solutions for 1 through 6. So we will be getting into some negative solutions in future lessons. Today we're just going to focus on the positive values because we're going to relate it into our radical exponents. We have our x squared equals 9. So we're thinking what number times by itself equals 9. And our x is going to equal 3. Now, one way you can think about this is the opposite of squared is the square root. And so the square root of 9 is 3, so x is going to equal a 3. Now, so looking at number 2, if I have two numbers that equal 3, now there's not a real nice solution for 3. So we're going to, opposite of squared is square root, and we are going to have z equals the square root of 3 would be the solution that would multiply by itself to equal 3. So square root of 3 times square root of 3 equals a 3. Y cubed equals 8. So we're thinking of three numbers that multiply by itself to equal 8. Now if I did 1 times 1 times 1, that equals 1. 2 times 2 times 2 equals 8. So the cubed root of 8 is going to equal 2. So opposite of cubed is cubed root. And so y is going to equal the cubed root of 8. So we're thinking of what number times it by itself 3 times is going to equal 8. That's going to be 2. What number cubed equals 1? Well, that's going to equal 1. The cubed root of 1 equals a 1. It's because 1 times 1 times 1 equals 1. Now, 3 squared times 3 to the 7th equals 3 to the x. We kind of learned about this the last time. I have 2 3's, and then I'm going to have 7 more 3's. Altogether, we've got 9 3's. So that's going to equal 3 to the x. Now we're trying to figure out what x equals. Well, it's going to equal this 9 here. So it's we're just adding the 2 and 7 to get 9. So we don't need to write this out every time, but that's kind of what's happening. So x is going to equal 9. 2 to the 3rd squared means 2 to the 3rd times 2 to the 3rd. There's 3 2's in the first section. There's 3 2's in the second section. Altogether, there's 2 to the 6. So when we have a power to the power, we're multiplying those exponents. That equals x. Now, the power is, x is not the power. So it's the whole thing, 2 to the 6. So 2 times 2 is 4, 8, 16, 32, 64. So x would equal 64. It's asking what this whole thing is equaling. Okay, so now that we're going to kind of be thinking about this number 1 while we do number 7 here. We have consider the function y equals 9 to the power of x. Now, when you spent a lot of time on this last year, it's an exponential function. Whenever you have an exponent, it's going to be like a straight up and down function. We're going to fill in the tables. We're going to put a 0 in for x. 9 to the 0 power, anything to the 0 power is a 1. 9 to the first power is 9. And 9 squared is 9 times 9, which is 81. We're going to go ahead and graph this on this graph. We have 9 to the power of 0 is 1. It's going to be kind of low on our graph. 9 to the power of 1, it's almost to 10. And 9 squared, it goes all the way to 81. And then we're going to just connect that into an exponential graph. Exponentials go straight up and down. Now, if it was a half, it's going to be kind of low. It's a little more than 1. But if you think about it, 9 to the 1/2 power is, we're looking at two things, 9 to the 1/2 times 9 to the 1/2 is going to be 9. So this is another way of saying 9 to the 1/2 is going to be squared. And what number times by itself equals 9? Well, that's going to be a 3. So the estimate of 9 to the 1/2 is a 3. So how do the 3 and the 9 relate? Well, 3 is equal to the square root of 9. So that is what 9 to the 1/2 power is going to be equal to. Number 8, we're going to consider the function y equals 3 to the power of x. We're going to fill in the tables with values. 3 to the 0, anything to the 0 power is a 1. 3 to the first is 3. 3 squared is 9. And let's go ahead and graph these on this chart. We have at 0, we're at 1. At 1, we're at 3. And 2, we're at 9. Gonna graph our exponential. If we had a half, it's going to be like a little more than 1, somewhere in between 1 and 2, maybe 1.3. We're the 3 to the 1/2 times 3 to the 1/2 is 3 to the 1/2 squared, and that's like saying this. We're going to multiply those exponents. And 1/2 times 2 is going to be a 1. Half of 2 is 1, so this is going to be 3 to the first, which is 3. So 3 to the 1/2 has to be equal to the square root of 3, because we need two things that multiply to just equal 3. Let's do a to the 1/2, a to the 1/3. So if you have a 1/2, what happens is we're going to have a 2 here. It's the square root of a. But if it's a square root, we don't write the squared. If it's a cubed root, we're going to put a little 3 here, the cubed root of a. Now let's go ahead and evaluate some of these expressions. 25 to the 1/2 means the square root of 25. That equals 5. 8 to the 1/3 means the cubed root of 8, which is going to equal 2. Square root of 15, if it's to the 1/2 power, it's kind of like this, 2 and a 15 here. Square root of 15, that doesn't really simplify. And when it's a square root, we don't write our 2 there, so it's just a square root sign. But if it's a 1/3 power, it's like the cubed root of 2. That doesn't simplify at all. So far in this section, all the rational exponents have had numerators of 1. If the numerator of a rational exponent is not 1, we're going to use this property coming up to property of rational exponents to rewrite the exponents as radicals. So properties of rational exponents, if you have a to the m divided by n, we have a to the 1 over n all to the m power. We can write it as the nth root of a to the m power. To understand why this property works, consider the following. Using exponent rules, we know that 3 to the 1/4 is saying the 4th root of 3, because 3 to the 1/4 to the 4th power is going to equal 3. But what about 5/4? Using exponent rules, 3 to the 5/4 is equal to 3 to the 1/4 to the 5th power, which means that 3 to the 5/4 can be written as the 4th root of 3 to the 5th. Since 3 to the 5th is 243, we could just write 3 to the 5/4 equals the 4th root of 243. Alternatively, we could express the fraction 5/4 as 1/4 times 5 instead. So using exponent rules, we could get 3 to the 5/4 equals 3 to the 1/4 to the 5th power equals the 4th root of 3 to the 5th. So we're going to do some practice problems using rational exponent notation. 3 to the 15th power, we're going to use this as rational means a fraction exponent. So we're going to say the base is 15. This is going to be to the 8. The 3 goes in the denominator. So whatever number you have here is going in the denominator. Whatever number is here goes in the numerator. So number 15, we're going to have 7 to the 4/3. Now we're going to go 16 and 17, we're going to go backwards. So we have the 4th root of 31 to the 5th. We can write it like this, or we could write the 4th root of 31 to the 5th. Either one of those is fine. 17, we have the 7th root of 2 to the 3rd, or we could write it as the 7th root of 2 all to the 3rd. Now we're going to figure out these without a calculator. We're looking for 3 numbers that multiply by themselves to get equal a -8. So we want 3 numbers. So I know the cubed root of 8 is 2, because 2 times 2 is 4 times 2 is 8. But we want them to multiply to be a -8, but they all have to be the same number. So if I take a -2 times a -2, I get a +4. 4 times a -2 is a -8. So this is all just going to equal a -2. Now on this one, the negative is separate from the cubed root. So I just am looking for 3 things that multiply to equal a +8. That would be 2, 2, and 2. So they're going to come out as just 1, 2. I'm going to have a negative and then a 2 here. The negative stays because it is not part of the root. We're just going to keep the negative. The cubed root of 8 is a 2. Now 16 to the 1/4 power, that's going to be the 4th root of 16. So I'm looking for 4 numbers multiplied by themselves to equal 16. Now I can figure this out by making a factor tree. 2 times 8 is 16. 8 is 2 times 4. And 4 is equal to 2 times 2. If you look at this, I have 4 2's that multiply all to 16. So the 16 to the 1/4 power is just equal to 2. Number 20, we have -16 to the 1/4 power. This is equal to the 4th root of -16. I'm looking for 4 numbers that multiply by themselves to equal a -16. So 2 times 2 is 4 times 2 is 8 times 2 is 16. But we are looking for a -16. Now what happens if I make all of these negative? -2 times -2 is a +4, and -2 times a -2 is a +4, and 4 times 4 is also 16. So there is no number that will multiply together to equal a -16. So I'm just going to write DNE for does not exist. There's no solution. This is undefined. Now we're looking for 6 numbers that multiply to be 64. I'm going to just break this down to be 8 and 8. You can think of any 2 numbers to equal 64. 8 is 2 and 4. 4 is 2 and 2. And same thing, 2, 4, 2, 2. So we have 1, 2, 3 2's and another 3 2's all together. 6 2's equals 64. So this is just going to equal a 2. Number 22, we're looking for 3 numbers, the cubed root of -27. 3 numbers that multiply to equal 27. Well, I know 9 times 3 is 27, and 3 times 3 is 9. So 3 times 3 is 9 times 3 is 27, but I'm looking for a -27. Let's see if this works. -3 times -3 is +9, and 9 times -3 is -27. So this works just to be a -3. Okay, number 23, we have the cubed root of -64 all to the 4th power. So we're looking for 3. I want to do what's inside the parentheses first. I'm looking for 2 numbers that multiply to -64. Well, let's just do 64. I've got 8 and 8, and I've got 2 times 4, and 2 times 2, and 2 times 4, and 2 times 2. So I've got 6 2's. I'm looking for groups of 2. So I've got 3 2's here and 3 2's here. We times those together equal 4. So 4 times 4 is 16 times 4 is 64. But I'm wanting them to equal a negative 64. So if I do negative 4 times negative 4 times negative 4, that will equal 64. So the cubed root of negative 64 is just negative 4, and then we're going to take that all to the fourth power. Now negative 4 times negative 4 is 16. 16 times 4 is 64, and 64 times 4 is 256. So this is all going to equal a positive 256. If I have 4 negatives, that will be equal a positive. Now number 24, I have a negative exponent. I never want to have negative exponents, so I'm going to take that denominator, I'm going to move it to the numerator. This is going to equal 27 to the positive 2/3. I take and rewrite it as a radical. The cubed root of 27, 3 times 3 is 9, 9 times 3 is 27. So all of this is going to equal a 3. We take 3 and square it, it will equal a 9. 25 is also a negative exponent. We don't want any negative exponents. We're going to take it to the denominator. I'm going to have 1 over the square root of 16 cubed. The square root of 16 is a 4 cubed. 4 times 4 is 16, times 4 is 64. 26 we're evaluating with the calculator, and we're going to round our answers to 2 decimal places. So in these we can just type them right into the calculator. If you need help with this, make sure you see your teacher. Number 26 is going to be negative 1.92. On 27 we get 22.50. And on 28 we're going to get 0.38. Number 29, we're looking at each set of 3 numbers. We're going to cross out the expression that's not equal to the other 2. So if I have the 4/5 power, the 5 is the root. So this is going to be the 5th root. This is the 4th. So this middle one is not the one we're looking for. Number 30, we have 7 to the negative 4/5. If I move it to the denominator, that would be 1 over 7 to the 4/5. The 5 is the root, so we want this one here. We're going to cross out the middle one as well. Number 31, we have the square root of 5 to the 3rd power. If there's not a number, it's like a 2, and that would be the denominator, so these two are going to be the same. That third one is not. 32, we have 1 over the cubed root of 5 to the 3rd power. That is like we have a little small 2 here. That's the root. Now both of these have a root of 2. But since this isn't in the denominator, we want to keep it there. But let's kind of look at these other 2. If I have a negative, I just keep it the same. This is up on the numerator, but if we have a negative exponent, that's where we're going to take and put it in the denominator, where I have the cubed root of 5 cubed, or we can think of it as 1 over 5 to the 3/2. So these 2 are going to be the same. We're going to cross out the middle one. Number 33 to 44, we're going to just match. 33 is 7 squared, which is 7 times 7, which is 49. That will equal H. 7 to the negative 2, that's going to be 1 over 7 squared, which is 1 over 49. That is going to be part C. 41 is 7 to the 1/3. That's going to be the cubed root of 7. That will be G. 34, 7 to the 1st is just a 7, which is going to be J. 7 to the negative 3 is going to equal 1 over 7 to the 3rd, which is going to be 7 times 7 is 49, times 7 is 343. This will be D. 7 to the negative 1/3 is going to be 1 over 7 to the 1/3, which equals 1 over the cubed root of 7. That will be F. Anything to the power of 0 is 1. That will be B. The 7 to the 1/2 power is the square root of 7. We're looking at E. 7 to the 3/2. That will be the square root of 7 to the 3rd. You could also say that as the square root of 7 all cubed. Now the square root we don't usually write, so I'm just going to erase these square roots. So we just got to look and see which one matches it. This would be L. 7 to the negative 1 is going to be 1 over 7. That's going to be K. 7 to the negative 1/2 is going to be 1 over 7 to the 1/2, which equals 1 over the square root of 7. This is I. And 44, 7 to the 2/3. This is going to be the cubed root of 7 squared, or we could write it as the cube root of 7 squared. Both of those would work, but when we're looking, this is going to be A. So we're looking more for this first one. "45, we're going to find a perimeter. Perimeter means you're going around the rim of an object with a square with area of 2 centimeters. So we're looking for two sides, two things that multiply to equal 2. And that would be the square root of 2 times the square root of 2. So if all of the sides are square root of 2, we add them up. We're going to have 4 of these square root of 2's. To calculate the annual inflation rate, R, in decimal form of an item that increases in value from P to F over a period of n years, you can use the equation R equals F over P to the 1 over n minus 1. We're going to find the annual inflation rate to the nearest hundredth of a percent of a house that increases in value from 300,000 to 325,000 over a period of 4 years. N is going to be our years. P, we're increasing from P to F. So P is going to be our principal or our starting amount. F is going to be our final amount. And then we're going to calculate the R. So we're going to take our F we're going to plug everything into this equation. Our F is going to be 325,000 divided by our P, which is 300,000. And then we have 1 over 4 minus 1. So we're going to go ahead and type this into our calculator. Okay, and so we're looking for the interest rate. When we type this in, we're going to get 0.0202. This is in decimal form. To get it as a percent, we're going to take that decimal, we're going to move it 2 places to the right. This would be 2.02% inflation over that 4-year period.